And so now we're broadcasting. What we want to do, and feel free to ask questions. I know sometimes students won't say anything when they're actually broadcasting. Feel free to ask questions. First thing we're going to do, we'll talk about the layers again. And even though we go over and over this, it's important to know. So in your mind, think about them. Okay, we did chapter 4. We talked about the physical layer and what were the key things. What are the 3 different media we can use? All right, send across wire. Wireless and fiber. Chapter 6, what's an important point in chapter 6 is, does it make a difference when it leaves here what media it's going to go across? It doesn't, right? I mean, you still get the internet. Whether you're on your phone, you still get the internet, even though that's Wi-Fi in here, right? Okay, or 3G, 4G, or I mean, somehow you get into another device, and then when it gets to another device, that's another protocol like Ethernet that gets it between the devices, and then some protocol that sends it across the world. And in most cases, are you using then all of these? You are. You're using all of them. Okay, so. Let me diagram that a little bit. So this is the switch here in the room, okay? And that switch is connected to a multi-layered switch, which is connected to a router. And that router, in our scenario, acts as our firewall. And that is where network address translation takes place. This is connected eventually to another router. Okay? And that router, so to speak, is our connection into the internet. And then that router connects the rest of campus. And not giving a lot of details, but there's a firewall, eventually a multi-layered switch, more powerful than this one, so to speak, and then lots of other switches across campus. And access points across campus so you can connect in using Wi-Fi. That makes sense? So if you're in this room, and like we mentioned the other day, most of you probably have your phone set to Wi-Fi, right? So you connect in, and this is where it goes. So from your phone, you're wireless to the access point. It's right out in the hall. You can walk out there and see it, sitting up in the ceiling, not very far down the hall. A little light in it. It's a Cisco device. So we go wireless, then it goes wired to this switch, which is in the administration building. And then from the administration building, we need to get somehow to here, which is, this is in another building. So that's fiber. This is fiber, just an example. This is all wired in here. So in chapter 6, we talk about media independent. That's what it means. You It all works. It doesn't care which medium. Because what takes care of putting the information on the medium? The physical layer. The physical layer puts the bits on the medium. Does the physical layer care about anything up above there? No, it just puts the bits on the medium. And so then it goes to another device. So in this case, if you're sitting on a PC in this room, that PC sends that information to the switch. So the physical layer figures out how to put the bits on the wire to get to the switch. When it gets to the switch, how does the switch handle the information? It needs a what? What's on the very outside of all this? Let's back up a little bit, right? You have data. Let's say you're going to a website or you're pinging. You have data. Your data. Then what happens here at layer 4? So your data, let's say your data is an image that you're sending someone. Too big, right? So what does it have to do to that big image? It's got to take it out into encapsulation. Yeah, we're going to encapsulate it with an address at the next layer, but can we send the whole image in one big piece? Yeah. TCP is going to say, how can we transport the layer? How can we transport this information? So it takes it and splits it up, creates segments. Creates segments. And the transport layer, are we going to send it TCP or UDP? For right now, we haven't talked a lot about that because that's the next chapter. That's the next chapter. But in general, what's the difference between those two? TCP.
The difference between downloading and streaming?
Yes. It's great to use an example because when you download, if you're downloading some software, it's usually all TCP. Okay? And it's going to check and make sure all of that has arrived before it ends a session. Okay? Session can't end until it has everything. That doesn't work if you need to stream a movie. You could download the movie ahead of time, right? You'd have to do it ahead of time. You can't say, oh man, let's watch this on Netflix right now. No, you want it streamed. You want the bits to just come in and doesn't have time to go back and check, so it's UDP. How is the data presented? Question. I'm sorry, I thought somebody had a question. Oh, we're good? And how do we connect into the application? So what we're concerned about today is what happens in the network layer, which is really quite simple. Okay? And that's going to happen, in our case, it's going to happen in some type of a routing device. Okay? Like this multi-layered switch. Or what we'll look at later on is the skills-based lab you did. Okay? And how the routing looks in there. And we're going to take a look at that in a minute. So this is our emphasis today, right here. What do we call it? We get the segments, we put port numbers on them, so to speak. We're being generic now. And then the segment comes here and Corey said earlier, we encapsulate it. What do we put on at the network layer? You know? It's what's going to get it through the internet. The internet's going to look at the network layers, the crucial, well, all three of those bottom layers are crucial, but it's going to look at what to get it there. What did we mention before? It's going to look at the IP address to get it to the destination. It's going to look at the destination IP. At this point, we call it a packet. So now we have data. The data is split into segments. Okay, data is split into segments. And then each of those segments is created. We create a packet with the IP address. And then we already talked about the data link layer. How do we link? For example, how do we get it from your phone to the access point? Okay. There's some electrical engineer figured out how to put the bits in the wave, radio wave in the air. They put the bits in the wave. But somehow the access point has to know it's Jordan's phone and not my phone. So it keeps track of what? What happens at the data link? How can it distinguish between two devices? This is supposed to be an easy answer. So don't make it difficult. What is unique about two phones separate from the IP address?
The MAC address?
Right, the MAC address. So it keeps it separated by MAC address. So remember, we talked about here we create a frame, and on the frame it can put a MAC address. So that'd be the last bit of encapsulation. And then it gets to the next device. Once it gets to a routing device, the router then can take the MAC address off, look at the IP address, and see where's the next best way to send it. Next best way to send it. So data link, we're linking devices together. Network layer, I'm more concerned about path and IP address. So we developed, the other day, we did a lab in which you still have connected, right? We've got a switch. And that switch is connected to a router that you did here in class. Okay. That router is connected to a multi-layered switch. Which, believe it or not, is connected to another router. And that router is connected here. To a switch. So what you were concerned about is basically that everything from here on down. And this class, that's it. You got to be good at it. The final, the skills-based final, is almost identical to the midterm. I just add 2 or 3 things. You got to do a little more configuring. Some of the configuring I did is taken out. So you have to be able to, or you should be able to, pretty soon, take a PC, put it on a network, figure out that default gateway, figure out simple addressing for the PCs on the network. And then what I did was I created a way to leave here and get into the normal network. So once you got into here, you were able to go all the way out to the internet, right? If you configured it correctly. If we back up, how can a PC, you're sitting at your PC, how can you get to some location on the internet, like, I don't know, Facebook, or maybe you're going to Dell to look something up, or the PC obviously can't have all the information you need to get there, right? But what do you have? If you type in Dell.com, what happens first before you can actually go there? What do you have to get there? You need the IP address, right? So what finds that for you? Yeah. What do we have to put in order to get our workstations to the internet? Is that a good enough hint? Yeah, you gotta be able to get to a DNS server. So you get to a DNS server and it sends you back an IP. I'm being a little generic. Once you have a destination IP, you can send it out to the internet. So how does the device here know to send it up towards the internet rather than look for a device in your network. It's because of your what? Is your default gateway. You're saying, if that isn't locally, then move it up to the next layer. Move it up to the next layer. Here's an interesting thing. I think it's interesting. You might think it's boring, but anyway. Does the website know you're coming to it? No. Is there any connection between you and the website you're going to? No. It's connectionless. There is no connection. And does this layer guarantee, does this layer, not the layer above, does this layer guarantee it's going to get there? No, it's just best effort. Those are terms that are in the curriculum. If you haven't had a chance to read it yet, that'll help you get through it faster. It's just best effort. You know, let's throw it out there, see if it gets there. Right? So connectionless, we don't make a connection. What do you do, or what have we worked on that you could have used that would be more like a connection? When you logged into the work server, you created a TCP connection between the two. Whereas when you're going to a website, it's a unicast, right? It's just you and the website, but you're going to send it a packet and say, I hope they send some back, so to speak. I don't know if you did it that way or not. So does this router know where Dell is? Your router sitting here, for those of you that got the skills base to work, okay, the people that got to work, their router, okay, right, working this morning, right, we had all working this morning. That router doesn't know necessarily where Dell is, but what does it have? It has a destination IP, but it doesn't know exactly where that is, so it sends it out its what? Default gateway. This doesn't know, sends it to its default gateway. We keep defaulting until we get out to our ISP. And the ISP, though, has then routes in its routers that have the best path, at least to the next hop, to the next route. It's like if you need to go to Cedar Rapids, somebody might tell you, well, the best way to go is go to Charles City first, don't go to Clear Lake. Could you go to Clear Lake and get to Cedar Rapids? Right, that might not be the best path. So routers, very generically, talk to each other and say, this looks like it's the best path to get somewhere. And they share that information. And there's a whole course about that. Okay? So we went over a number of terms. Let's see if I missed any. We talked about encapsulation, routing, and decapsulation. You know, when it gets to the other end, it works its way back up. Takes this off, takes this off, takes this off, and eventually the data goes into your app, your browser, or whatever you use, your email, your FTP program, or whatever. Then when you want to initiate conversation, come down, gets encapsulated, can go across media independent, right? Of media. We talked about connectionless, best effort, media independent, and encapsulation. Let's look at just a couple examples, and then we're going to go back to doing some of this. All right. So I am going to take a look at is that big enough? Dakota, do you do me a favor? Could you turn down one or two lights? Because I think the rest of the time, we've got about another 10 minutes on the broadcast. I'm going to quit at 30 minutes. Okay. So, Corp 1 is a device. It's the device that all your devices are connected to. Okay? Now I'm going to do a show IP interface brief. This command is really handy. I'm abbreviating. Some of you might say, you know, I'm not real good at typing the commands yet, right? We might have some people that are thinking I'm not real good at that yet. You'll be fine. You'll get it. Okay. If there's anything that concerns me is the concepts. If you're not getting through the curriculum well enough. So this lists all these interfaces, and you can see them here: 192.6.8.9 and so forth. These are interfaces on this device, and I've converted them all to routing ports. So they're all connected to what? What do you think they're all connected to? Does this look familiar, Dakota? Mm-hmm. That's your router, right? Your IP, if we were looking at Dakota's router, it's .2. I'm using a .1 right here. So I have, what kind of connection is that? That's called a direct connection. We're directly connected. Those two devices have a wire between them directly. There's no other devices in between. Okay? So I don't know, if you want to, you could actually log into your router if you want to try to do that right now. So you can see, and I can see the interfaces, the protocol. Okay, we went all the way back up here. The status and protocol, they're both up for those interfaces. This one, 24, leaves my router, or this router, well, not mine, leaves Corp 1, and it goes to the next router. Okay, now we'll see why that's important. I mentioned it. I'm going to do an enable, and you can see I haven't set any of the passwords on this device, right? It's not fully configured like you would do. So I'm going to do a show IP route. It's going to show the routing table. So we have the descriptions here at the top. We have the codes. A C is a connected route. That means the device is connected. S is a static route. And then all the rest of these you don't have to worry about yet. You don't have to worry about. They're all routing protocols, which we don't cover. Well, we'll look at it before the year's out, but it's really covered next term. In fact, that's all you do. You just talk about routing protocols. These are all the connected ones. So each of these, if you would look at these, and there's some more further down. This isn't all of them, but it shows you that these networks are directly connected, and then it tells you what interface they're connected to. Then I physically typed these in. It wasn't very, not a huge challenge. I typed all these in. Can anybody tell me what they're pointing at? They look familiar? Dakota, can I pick on you? Right, doesn't this one look familiar? Yeah, that's your internal network, okay? That's the one Dakota did, just as an example. So I'm saying if I have a packet that has this IP address, the router's not really very smart. They're a very simplistic machine. It says, if this is the destination, all I know is I'm going to send it out this Ethernet port. It doesn't know anything else. It says, if this is the destination, I'm sending it out this port. It gets queued up, out the port it goes. Hopefully, whatever's on the other end of that port can figure out where to send it next. That's really it. The whole internet works that way. I'm being a little bit generic, but look at the destination. Where's the best path to send it out that port? And do we want it to do it very quickly? Yes, right?
Nope, nobody wants their network to be slow and cumbersome and not efficient. So if you look at this, it says if the address is a 172.16.00, and if it's subnet, 10 subnets, we're going to learn about that by the end of when it starts getting cold and so forth. And so it says, if it's not a 172, don't even look at these. A 172.16. I'm being a little generic, but look how fast that is then. Because if it doesn't need to go there, then it can look at one of these other ones. Where does it go if it's not here in the table? See this up here? Gateway of last resort. I'll show you that. So if the address you're trying to go to is nowhere's in the routing table, this router knows to send it out to its default gateway. So if you take any local network that has access to the internet, somewhere they have their devices pointing out to their ISP. At home, your little routing device at home, if you got one there, in there it has built right in, you didn't have to put it in. They have the default gateway pointing out to your ISP. And then once the packet gets the ISP, those routers, I don't know, they have, 120,000 routes in them or something out in the internet. I made that. I know it's like in that ballpark, but I don't know exactly. But then they can look in their routing table and find the next best direction to send it. And so remember the other day we did the, does this make sense? These are the ones that are connected. Fast Ethernet 024, right here it is. See, that's a different network, right? 192.168.100.0. I made that up, just decide what we're going to use. And so any packet that doesn't fit into this network gets queued up and goes out that port. That port's connected to the next router. And that router is connected to the switch up here, which then sends it out through the college network towards the internet. All right, any questions you can think of? All right, so I got about 2 minutes, and then we'll end the broadcast. So Dakota, could you turn the lights up again, please? So you initiate something that has to use the network, like you're using a browser. Data gets broken into segments, starts encapsulation, put an IP address on it, MAC address, if that's what the data link requires, and then the bits physically go on some independent media. It works because a physical layer will always make that work. Okay. Then when it gets to the other end, comes back in on some media, the physical layer takes those bits, converts it back in. Now you got a frame. Got the framing information on it, can take that off, look at the path. So if you're going through the internet, once it gets here, it says, okay, I need to send it out another port, encapsulates that, sends it out the port, comes back up to here, back out. So as it's moving through the internet, it never really leaves this layer above until it gets to the destination. Then it goes up. If it's TCP, it's going to have to keep track. Do I have all the segments? Once it gets all the segments and the session, if there was encryption, it decrypts it, goes back into your application.